This video is going to cover vector additions. So if I give you two vectors, and what's a vector? A vector is anything that has a magnitude and a direction. Magnitude meaning a measurement, and a direction meaning is it going north, south, east, west, up, down, right, left, 30 degrees north of west, so on and so forth. So what are some things that are vectors? Velocity is a vector because it gives you a speed as well as a direction. When I say 60 miles per hour, then I'm just talking about speed because I've just given you a number. I've given you a magnitude. So that measurement is just called a magnitude. However, if I say 60 miles per hour due east, then I'm giving you a magnitude, which is a number, as well as a direction. So then it becomes a velocity vector. Vector is something that has both magnitude and direction. Anything that doesn't have direction is called a scalar. And other examples of vectors are displacement. Displacement requires a good understanding of direction. So if you say I'm going 10 meters away from the school, or I'm coming 20 meters towards the school, then you're giving me a measurement, a magnitude, as well as a direction. So whenever I use the word magnitude or measurement, those are interchangeable words. But that direction part is important. If you're given a direction as well as a magnitude, then you've been given a vector. So displacement's a vector, velocity is a vector, acceleration is a vector because acceleration tells you how fast are you increasing your velocity and in what direction. Gravity accelerates you down towards the ground. When you're driving your car and you hit the brakes, then the acceleration is in the opposite direction of the original motion of the car. So acceleration again requires a magnitude, how fast are you speeding up or slowing down, but also a direction. So examples of vectors are displacement, velocity, acceleration. Examples of measurements that aren't vectors would be measurements that don't require a direction, like speed. If you're going at 60 miles per hour and they don't give you the direction, then that's a scalar quantity. Speed is an example of a scalar quantity. And time, again, time is a measurement. It gives you a number, but it doesn't give you a direction. So once again, that wouldn't be qualified as a vector. It would be qualified as a scalar. Another example would be mass. My mass is 60 kilograms, or 80 kilograms, whatever my mass may be. And that, again, does not give you a direction. It just tells you my mass. So if it doesn't give you a direction, it can't be a vector. And if it's not a vector, it's called a scalar. Scalar is spelled S-C-A-L-A-R. Vector is V-E-C-T-O-R. You'll find them in your textbook. You'll be reading about them in the next day or two. So when it comes to vectors, you've got to add them and you've got to subtract them. You've got to know how to add and subtract them. So the simplest thing, the simplest addition of vectors are if you have two vectors. Let's say one is vector A and one is vector B. These could be velocity vectors. They could be the velocity of a car. They could be acceleration vectors. They could be displacement vectors. They could be as simple as you walking. Someone could say, okay, you walked 10 meters and then you walked another 5 meters. So one is vector A, the other is vector B. Whatever the numbers go with it, we'll put them in later. Right now I'm just using letters to identify the vectors. So if I have two vectors that are going in the same direction and someone says, can you add them? Well, that's the easiest one to add. When you add two vectors in the same direction, you just put them head to tail. What does that mean? This is the head part of the vector, this is the tail part of the vector. So when you add the two vectors, you just put them head to tail like this. You connect them head to tail and you just add them directly. So if this was, let's say, 10 meters, you walk 10 meters to the right and then you walked 5 meters to the right, and someone says, what is the resultant of those two vectors? What is the sum of those two vectors? You'd simply add those two numbers, 10 plus 5, because they're both going in the same direction. So if this was a velocity and this was a velocity, this was 20 meters per second and this was 5 meters per second, and someone said, what is the resultant of those two velocities or those two vectors? What is their resultant vector? You'd say, okay, that's 20 meters per second, that's 10 meters per second, so the resultant would be 20 plus 10 or 20 plus 5. Whatever A is and whatever B is, you just directly add them if they're going in the same direction. Now, if they're going in opposite directions, that's also not a problem, because if you have to subtract them, that's easy to do, because when they're going in opposite directions, it's like taking this vector and making it into a negative b. If this is a positive b over here, if I flip its direction, it becomes a negative b. So that's an example of a vector subtraction problem. You're subtracting two vectors that are going in the opposite directions. So you got to be careful about the direction of a vector. Make sure you understand whether they're going in the same direction or they're going in the opposite direction. If they're going in the same direction, just numerically add the two vectors. If they're going in opposite direction, just numerically subtract the two vectors. So that's the easiest part. The more complicated part comes up when the two vectors are not going in the same direction and they're going perpendicular to each other. For example, you have two vectors over here, vector A and vector B. let's say this is a displacement vector and this is a displacement vector. So they say that John Doe travels 6 meters to the right and then 3 meters to the south. If that's the case, then they say, what is the resultant? Meaning, where is John Doe now? How far is he from where he started off? So when they ask you to take the sum of two vectors that are perpendicular to each other, all you got to do is you got to follow this first rule. The rule of vector addition is always add them head to tail, meaning redraw the vectors so that one vector's head is touching another vector's tail. So right here I've drawn vector A and vector B so that one vector's head is touching the other vector's tail. That's rule one. Always make sure that they are touching each other head to tail. Rule two is never ever change the direction of the vector. When you're adding them, you cannot change their directions. For example, vector A is pointing to the right, it's still pointing to the right. Vector B is pointing down, it's still pointing down. So make sure you never change the direction of the vectors. And rule number three is don't ever change their size. If this vector has a certain magnitude and a certain length, try and redraw it the same way over here. If this one has a certain magnitude and certain length, make sure it's drawn over here. Don't change the actual vector. All right, so if you have these two vectors, A and B, and you're being asked to find the sum of these two vectors, well, this goes hand in hand with trig. Because if you have this side and these are perpendicular to each other, well, then they make a right triangle. So you can find the resultant vector by just doing a squared plus b squared equals c squared, which is Pythagorean's theorem. A squared is this side, b squared is this side, and then this side would be c squared. That would give you this side, the hypotenuse, which is called the resultant vector of vector A and vector B. So if I ask you, if I give you a problem where you have two vectors that are perpendicular to each other, and I ask you, give me the sum of those two vectors, give me what A plus B is, you cannot numerically just add them, just like we did over here. You can't just numerically add the value for A with the value for B. You will have to do Pythagorean's theorem. You'll have to do a squared plus b squared equals c squared to get the hypotenuse side. So that's how you find vectors you find the resultant vector of vectors that are perpendicular to each other. We're going to be reviewing some of this in class also. Hopefully this was a good introduction to what we're going to get into in class.